Hello students, today in this lecture we are going to discuss one of the most important topics of context-free grammars, that is normal forms. In this particular video lecture we are going to discuss one of the most important normal forms, that is Greibach normal form, which is abbreviated as GNF. Now first we can see what are normal forms and its needs. As while discussing the simplification of grammar, which we already discussed in previous video lectures, we come across that by reducing or simplifying the grammar gets minimized but does not get standardized. This is because the right hand side of the production have no specific format. Normalization is performed in order to standardize the grammar. It is performed using normal forms. So the most popularly used normal forms are Chomsky normal form and Greibach normal form. In this video lecture we are going to discuss Greibach normal form, which is abbreviated as GNF. Now what is Greibach normal form? A context-free grammar is said to be in Greibach normal form if all its productions satisfies one of the following conditions. First condition is A produces small a, then capital A, capital S and capital B. That is, the right hand side contains one terminal which is followed by any number of variables. Or second condition is A produces small a. That is, the right hand side contains only one terminal. Here capital A, B and S are non-terminals, that is variable, and small a is a terminal. From the above conditions we infer that to be in Greibach normal form, all the productions must derive either a single terminal followed by any number of non-terminals, which we already see in condition A, or only a single terminal, which we see in condition B. Now we need to get how the steps for converting context-free grammar to Greibach normal form. Step 1. Convert the grammar into Chomsky normal form. If the grammar is not in Chomsky normal form, we need to first convert into Chomsky normal form. Then in step 2, if the left recursion exists in the grammar, then eliminate it. We will discuss it in later slides. Then in step 3, in the grammar, convert the given production rule into Greibach normal form. Now left recursion. What do you mean by left recursion? A production of grammar is said to have left recursion if the leftmost variable of its right hand side is same as variable of its left hand side. A grammar containing a production having left recursion is called as left recursive grammar. Let us see in the example, if S produces SA and S produces epsilon, then in S produces SA, we see that S is in the left hand side, also S present in the right hand side. So if S produces immediately on the right hand side, then by this S, which is marked with the red symbol, the left recursion exists. So this grammar is left recursive grammar. So we need to eliminate this left recursion, which can be eliminated by seeing this productions. Like A produces A, this is the general form, like A produces A alpha and A produces beta. Here beta does not begin with A. Then we eliminate left recursion by replacing the pair of productions with A produces beta A dash and A dash produces alpha A dash and A dash produces epsilon. So this productions are replaced by these productions in order to eliminate the left recursion. Now we see this concept by solving some examples. Consider the following grammar and eliminate left recursion. E produces E plus E, E produces E into E, and E produces A. The grammar after eliminating left recursion is E produces. Here you can see that you need to compare this grammar by the standard form which we discussed in the previous slide, like A produces A alpha and A produces beta. Here A stands, here E A stands for E and beta stands for A. So according to that format, E produces beta A dash, and A dash gives to alpha, which is this, plus E A dash and into E A dash, and A produces epsilon. Like in the second example, consider the following grammar and eliminate left recursion. So A produces ABD, A produces AA, A produces A. So here left recursion is there in terms of capital A. Also B produces BE and B produces small b. So here left recursion is there in terms of capital B. So grammar after eliminating left recursion is this. Here A produces beta A dash and A dash produces alpha A dash, then alpha A dash and epsilon. So in a similar way, B produces B dash and B dash produces B dash and B dash produces epsilon. Now we solve the context-free grammar into Greibach normal form. Suppose a grammar is given, so we first need to consider whether this grammar is already is in Chomsky normal form or not. As we can see that this grammar is already in Chomsky normal form and there is no left recursion. So the production rule, A produces SA. We check and it is not in Chomsky normal form. So we substitute S produces HB and H produces AA in it. So now the grammar will become this. As we substitute this S by HB and we substitute this S by AA. So the above grammar will convert to this form. Now the production rule, S produces HB and B produces HBA is not in Greibach normal form. So we substitute H produces A in the production rule. This H produces HB and B produces HBA as this. We again go to the previous slide. Here we can see that H produces A is also there. So we replace these H by H produces A. So we get this grammar. Now we will remove the left recursion from A produces A. So by removing the left recursion, we need to go to the standard form of elimination of left recursion. Like A produces A, like beta in terms of A, beta A dash, and then beta A dash is there, then A dash gives to A dash, and A dash gives to epsilon. Now we can see that C produces epsilon is there. So there is a possibility of null production. So we need to eliminate the null production. As you remembered, we already discussed the elimination of null production in our simplification of CFG. So in order to eliminate null production or remove null production, we need to put the value of C produces epsilon in place of C. Like A produces AC and A produces ABAC, and in the next time we need to put epsilon in place of C. So A produces A and A produces ABA is there. So our grammar will become this after removing the null production. Now the production rule, S produces AA is not in Greibach normal form. So we substitute the value of A produces this in the production rule, S produces AA as this. So we get the value of A, this, which is already in Greibach normal form. So we need to replace the value of A in S produces A in the first A. So we get this grammar. We also replace the value of A in C produces AA also. So we get this grammar. Now the production rule, C produces AAC is not in GNF. So we substitute the value of A in the production rule, this. So we get this drama. So the above context-free drama is in Greibach normal form. So these are some of the assignment questions which are already based on your RTO exam paper. So you need to solve these questions and send it to me through email in the next 2 days. Thank you for watching this video.